So this question asks us to determine if each function is even, odd, or neither. So let's remind ourselves of the definition. A function is even when f of negative x is the same as f of x. And that will also mean what? If you have the value for f of x is the same as f of negative x, that's also going to be symmetric with respect to the y-axis. A function is odd. What happens when a function is odd? F of negative x is the same as negative f of x. So if we look at that kind of a picture, here is f of negative 2. Let's see. Let's say I have f of 2 is here, f of negative 2 would be there. That's going to be symmetric with respect to the origin. Remember, that's when you fold it over twice, fold it over the y-axis, fold it over the x-axis, and the points match. So our first example here is f of x is 3x to the 4th minus 5x squared plus 1. We need to look at the behavior of f of negative x. What is f of negative x? 3 times negative x to the 4th minus 5 times negative x squared plus 1. But remember, a negative times a negative is a positive. So negative x times negative x is just positive x squared. This becomes minus 5, positive x squared plus 1. How about negative x to the 4th? Negative x, negative x, negative x, negative x. That'll also be positive x to the 4th. So you will notice after we substitute x with negative x, we get the fact that f of negative x is the same as f of x, so the function is even. Which means it should be symmetric with respect to the y-axis. I want to take a look at that. So let's graph it on Desmos. So we've got f of x equals 3x to the 4th minus 5x squared plus 1. And sure enough, you can see that it is symmetric with respect to the y-axis. F of negative 1 is the same as f of 1. Right? F of a half is the same as f of negative a half. So indeed, symmetric with respect to the y-axis, that is an even function. All right, the next question we had was g of x is 5 over x to the 3rd power. So we're going to plug in negative x for x. So what is g of negative x? That is 5 over negative x to the 3rd power, which is 5 over negative x, negative x, negative x, right? Negative, negative is positive times negative is negative 5 over negative x cubed. That is not the same as g of x, but it is the opposite of g of x. Okay. So g of negative x is the opposite of g of x. Therefore, our conclusion is that g is an odd function. So that should be symmetric with respect to the origin. It should be. All odd functions should be symmetric with respect to the origin. Which means if you fold it twice, the points match up. So let's take a look at the graph of that. So we've got g of x is 5 over x cubed. So can you see that, for example, f of 2 is here. which is a different sign, but the same absolute value of f of negative 2. So f of negative 2 is just the opposite sign of f of 2. If you fold it over twice, right? If we could fold it over here, and then fold it here, and then fold it again, the points are going to match. So indeed, this is an odd function, and it is symmetric with respect to the origin. Our next question is h of x is 3x plus 1. Look at the graph first this time. And ask ourselves, is it symmetric with respect to the y-axis? Is it symmetric with respect to the origin? Y-axis would be even, origin would be odd. Is the y-axis a mirror? No. If you fold it twice, like, does 1, 4 become negative 1, negative 4? No. So it is not symmetric with respect to the y-axis, which tells me it's not even. It is not symmetric with respect to the origin, so it's not odd. How do we prove that? We look at h of negative x, which is 3 times negative x plus 1, which is negative 3x plus 1, which is not the opposite of h of x, which would be the negative of 3x plus 1, which would be negative 3x minus 1. So this is neither even nor odd. And our last question here is k of x is 7. And again, let's look at the graph first. Symmetric with respect to the y-axis means that it is even. Symmetric with respect to the x-axis means that it's odd. So if I graph k of x equals 7, what does it look like? Well, there's that blue line. Is the y-axis a mirror? It sure is. That is symmetric with respect to the y-axis. Therefore, it has to be even. Now, how do we prove that? Remember, an even function gives me f of negative x is the same as f of x. So what is k of negative x? K of x is 7, so k of negative x is also 7. So since k of x, everything is 7, k of x equals k of negative x, we conclude that this function is even.